Okay, with this particular problem, we're going to rewind back to geometry days where we were talking about the transitive property when you were doing all those proofs. So we're going to apply that though to a rate of growth. So if f grows at the same rate as g as x grows towards infinity, and g grows at the same rate as h as x grows towards infinity, then f also grows at the same rate as h grows to infinity. So if we can show that f is equal to g, and we can show that g is equal to f, or to h, then we could show that f is equal to h. It's that whole transitive property situation. So we're wanting to show that f equals g, we're going to show that g equals h, and if this is true, then we can say that f equals h. That's what we're really investigating here. So with f of x, we're going to start with this guy. We're going to look at the limit of f of x over h of x as x goes to infinity. Okay? F of x over h of x. And remember, if they grow at the same rate, then we're going to get a specific number limit. Okay? F of x in this case is the square root of x squared plus 5. Okay? But h, what value of h would work in this case? And what we want to do is if you think about this for just a second, the square root of x squared, think about that. If for h, the square root of x squared is equal to x. Okay, so I've got the square root of x squared plus 5. Well, for super large numbers of x, very, very large values, that 5 is inconsequential. It just doesn't matter when you're plugging in 200 billion. 5 more doesn't make a large difference. So we can actually compare this to x. Now, again, with a little bit of algebra, we want to get to a problem that we can easily find a limit as x goes to infinity. So if I've got the square root of x squared plus 5 over x, then I can rewrite this as x squared plus 5 over the square root of x squared. Now, this is a kind of a cool trick, but it follows our rules of algebra, right? I haven't done anything brand new or earth-shattering, although this is a very unique way to solve a problem. And the square root of x squared is just x. But since it's now under the radical, I can put all those radicals together and have x squared plus 5 over x squared, which is the same thing as the square root of 1 plus 5 over x squared. Now, how did that happen? Just like in our previous problem a minute ago with x plus sine x over x, what I did was I looked at this guy and I go, hey, this is the same thing as x squared over x squared plus 5 over x squared. If you add that fraction up in gray, then you get the item in blue, okay? And the limit as x goes to infinity now becomes the square root of 1, which is 1, because you get a large number right here in the bottom of this fraction. When you get that large number right there and the 5 doesn't change, that goes to 0. Okay, now we want to compare this again also to g of x. So what we're going to do is we're going to just change up colors. We're going to look at the not that guy, let's get it back over here to ink. The limit as x approaches infinity of g of x over h of x now, and we want to show that this also approaches a specific number. And so when we look at this, g of x over h of x, that's going to be 2 square root of x minus 1 squared over x. Okay, so now when we work with this particular guy, we want to look at kind of the same sort of situation. We can rewrite him using our rules of algebra like this. The square root of 2 square roots of x minus 1 over the square root of x squared. Remember, this accomplishes the exact same thing as the previous one in the darker blue. Notice, the square root of x squared is just x. That's what we wanted. But we now have it in such a way that we can sort this guy out. So I'll just come back here. And what we're going to end up with is splitting that fraction up. So 2 square roots of x over the square root of x minus 1 over the square root of x. And now, as we look at this as x goes towards infinity, by the way, this is all still squared. Okay, and what happens? Well, the square roots of x over here, they cancel out, just like these guys did a minute ago and gave us a 1. So in this case, though, I have 2. So when x gets really large, I have 2 minus 0 squared. Remember, the square root is still growing, even though it grows slow. The numerator doesn't change. So as x gets large, the numerator does not change. So you approach 0. 2 minus 0 squared, 4. Okay? Well, let's talk back about our basic thing. We wanted to show that these two guys grew at the same rate. So now we can look at the limit as x goes to infinity of, and then in this case we can look at f of x over g of x. In using our transitive property, then we can say that this is the same thing as let's see, how does the book, I want to kind of mirror the book on this so that we can see it correctly. This is f of x over h of x divided by g of x over h of x, right? Because those are the things that we compared. So when you multiply by the reciprocal, you get f of x over h of x times h of x over g of x. And those h's cancel out. And so we're left with then the limit of f of x over h of x times the limit of g of x over h of x, or divided by that limit. And so that's going to give us 1 over 4. And since that limit right there is constant, we know that these two different functions grow at the same rate.